Hey, welcome back, AP Calculus. Today we're looking at 3.5 derivatives of trig functions. So these are just things that you need to remember. If you remind me at some point, I'll give you a cheat sheet with all the derivatives for all the things you need. But the more you can do to memorize these now, because on your test you will not be given any kind of cheat sheet. You're going to have to remember all of these different derivatives and rules for derivatives. So the better you get at it now, the easier it's going to be to remember at the end. So let's try to memorize these. They're not too hard. So the first two, the two major ones really, are the sine and cosine. So the derivative of the sine is the cosine. The derivative of the cosine is the negative sine. And I always get those mixed up as well because they're basically the opposite of each other, but one has a negative and one has a positive. So yeah, I mean, I still forget this one because they're very similar. So don't feel like you need to immediately know what it is and for all time know what it is. Just be aware. Okay, the rest of them they're kind of related too, I guess, because the derivative of tangent is secant squared, derivative of cotangent is negative cosecant squared, and then secant is secant tangent, while cosecant is negative cosecant cotangent. So those ones are not really hard to remember, for me at least. It's just that the sine and cosine, because the sines and they're so closely related. All right, so let's go ahead and look at some examples here. So this is not so much conceptual as the position, velocity, acceleration stuff was. This is more just, hey, can you find the derivative of these things? So let's go over it. Part A, notice that we have x squared sine x. So we have x squared times sine x, even though we don't have the symbol there. So what we need to recognize is that in order for us to find this derivative, we need to do product rule, because we have two things that we can derive and they're multiplied by each other. Otherwise, we're just looking at one huge thing. We don't really know what we're going to do with it. So let's product rule this. We know that u is x squared, v is sine x. All right, so du is going to be 2x, and then dv is going to be cosine x. All right, so to derive this, we know that our product rule is going to be u dv plus v du. Our u is x squared, dv is cosine x, and then v is sine x. And then times 2x, I'm just going to put the 2x in front because it's neater there. So this is the derivative for our x squared times sine x. All right. Likewise for cosine x over 1 minus sine x, but this one is a quotient rule. Quotient rule, meaning we do v du minus u dv over v squared. So let's write this out. Our u is the numerator, v is the denominator. Okay, so we're going to do du, derivative of cosine is negative sine x. And derivative of v, well, derivative of 1 is 0, right? It's gone. The constant is gone. But we have negative sine x. So the derivative of sine x is cosine x, but we have that negative on it. So that negative stays there. Now let's arrange these. So we have 1 minus sine v times du, which is negative sine x, minus u dv. So cosine x times negative cosine x all over v squared. So 1 minus sine x squared. All right, we should probably go ahead and multiply this stuff out. So 1 times negative sine x, negative sine x. Negative sine x times negative sine x is positive sine squared x. Then here, negative times negative cosine is cosine squared x. And then 1 minus sine x squared. Okay, now remember when I said in trig and pre-calc that you guys are going to have to remember that stuff? Anytime we have sine squared plus cosine squared, that becomes 1. So I'm going to write 1, and then I'm going to put my minus sine x just so it's easier to see. Okay, so notice numerator I have 1 minus sine x. Denominator I have 1 minus sine x squared. I'm going to take one of the only one of those. And I'm going to cancel with one of the sine, 1 minus sine x is in the bottom. So this whole thing is just 1 over sine, 1 minus sine x. Alright, so the most important thing is to set up the quotient rule. Plug your stuff in. The algebra stuff is also important. So one of the things about calculus is not so much the calculus part, but people get hung up on, wait, I forgot how to trig, or I don't remember this trig identity, or I forgot how to algebra. Like, I didn't realize that we could use this algebra technique to simplify this expression. So just be very careful and aware of different things you can do in different situations. Okay, the next one. Weight hanging from a spring is stretched 5 units beyond its resting point. Its position at time t is 5 equals cosine t. No, s equals 5 cosine t. I think I said that wrong. What are the velocity and acceleration at time c? So you have this spring, right? And attached to this spring is some weight. And what happens is they stretched it 5 units and then they let it go. So in your brain, you can kind of figure out what's happening to the spring, right? It's going up and down and up and down and up and down. And while it's going up and down, it's going up and down ever slightly less and less each time until it's going to hit its point where it's at rest again, right? It's Newton's law. I forget which one it is because I'm not a physicist, but yeah, one of Newton's laws. So the next one, so it's asking us, all right, using this is the position, find the velocity and acceleration at time t. Okay, so I know that if I'm going to do the velocity, I'm going to do the derivative of that. So the velocity is going to be equal to 5, it's not changing, but the derivative of cosine is negative sine t. Okay, so the velocity is negative 5 sine t, and then the acceleration is going to be the derivative of this one. So the derivative of sine is cosine, so that's going to be negative 5 cosine t. Okay, and we're done. Pretty straightforward. And think about it. We'll talk about that later. Okay, for the next one, it says find equations for tangent and horizontal lines for f of x equals tangent x over x at x equals 2. Okay, so notice here, again, we have a quotient rule because we have a function on top divided by another function there. So my u, well, let's write down the quotient rule just so we don't forget. So v du minus u dv over v squared. All right, so my u is a tangent, v is x, du is going to be secant squared x, and then dv is 1. Right, the derivative of x is 1. All right, let's put this together. So we have v du minus u dv, so tangent x, and then we don't have to multiply by 1, right? Because tangent x times 1 is tangent x. Okay, over v squared, in this case we're going to have x squared. So we have this, right? Now here's the tricky part. We're not done, right? It's not just asking us for the derivative. We have to find the tangent and normal line. So what we know is that because this is the derivative, in order to find the slope at x equals 2, all we have to do is plug in 2 here. So we're going to 2 secant squared times 2 minus tangent 2 over 2 squared. So you can put this into your calculator The one thing to remember is that because our calculators don't have a secant button, they just have sines, cosines, and tangent. What we're going to do is we're going to input this as 2, and then the secant is going to be 1 divided by cosine. Well, we should put parentheses there, of 2 squared. Right, so 1 divided by, because it's squared, right, and we can't just say cosine squared, there's no cosine squared button. We have to do cosine of 2 squared. That's going to take our value and square it. And then we're dividing it because secant is the reciprocal of cosine. Okay, and then we're going to do the rest of it's fine, tangent over 2. We do need to remember also, though, that we have this huge parentheses here around the whole numerator, and then divided by 2 squared. Okay, so input that into your calculator, make sure everything's all good. In fact, I'll try it on mine, but I'm not sure if it's going to come out correct because it's proven to be weird at times. Oh, let's not use that calculator. Let's use... Is this the one? No. Is this the one? Let's try this one. Okay, so we said that we have... This is clunky. I'll just do it on my calculator. So we have parentheses, 2 parentheses, 1 divided by cosine 2 squared minus tangent 2 divided by 2 squared. So we get 3.433. So 3.433. 3.433. Okay, so this would be the slope of the tangent. Okay, so what we need to also do is we need to find the slope of the normal. Now, all we have to do is find the reciprocal. So if you do, I should show you how to do this. Okay, one way to pull up your answer that you had before. So once you inputted that, we got an answer, is you could do second answer. If you hit enter, it has that number stored. You could also take that number and store it. So you could say store, answer store into whatever number you want or variable you want. So you can do alpha A, hit enter. So anytime I put in an A, then it gives me back that number. We don't have to round it. We don't have to input it again. It's always there once we store it. So unless we delete the memory. So if we want to find the opposite reciprocal, then we're going to do 1 divided by A. That would be the reciprocal of A. 0.291. Okay, we'll write that down. 0.291. 0.291. Opposite sign as well, right? So negative 0.291 would be the slope of the normal. That's gross. Normal. And then all we have to do from this point is find the y for our function and then plug everything in. So let's go ahead and do that too, I guess. So we're just going to plug in 2 to the tangent x over x. So we're going to do tangent 2 divided by 2, negative 1.093, negative 1.093. So let's do this. Our point is going to be at 2, negative 1.093. And then we have our information for our normal line. I think we have enough room to fit all this in. So let's do this in black then. So again, point slope form, y minus y1 equals x minus x1 is the way we're going to want to go for a lot of these. So y minus negative is plus 1.093 equals, so we'll do the tangent slope first, 3.483 parentheses x minus 2. Now the nice thing about the slope for our tangent and normal line, well, our equation for our tangent and normal line, for the most part they look the same. It's just that our slope's different, so negative 0.291 x minus 2. Okay, so we just did the normal and tangent lines. Yeah, it was a process because we had to derive it, we had to plug our numbers in. The numbers didn't come out nice because we're dealing with trig functions and we're not dealing with pi's plugged in, so we're going to come out with stuff that's decimals. Alright, but that's pretty much it. Hopefully you guys are okay with it. It's going to take some time, and we are going to practice more trig derivatives and stuff, so you'll see them again. You'll see them off and on. It's not like we're just going to do this one time and you're going to forget about it until it's time for the test. Alright, good job.